Welcome to Gurukul Universal. Today I will be talking about artificial neural networks. What are they and how do they work? We will go through all the basics so that by the end of this presentation, you will have a better understanding of ANS. Let's get started. Artificial neural networks are based on interconnected neurons that mimic the working of a human brain. Neurons take input, process it through an activation function and generate output. Training of the network is done by feeding the input through a process known as forward propagation, which gives an output. This output is compared with the desired output and weights and biases are adjusted accordingly by the process of backward propagation, thus increasing the accuracy of the output. In this article we will take a look at the applications of artificial neural networks in various contexts. ANS, or artificial neural networks, are a type of machine learning model that resemble the structure and function of the human brain. They consist of interconnected nodes, or neurons, that are organized into layers. Each connection between nodes has an associated weight, which is modified according to the input data to make correct predictions or classifications. In the following slides, we will analyze some of the most frequently used ANS and look at their varied uses. Recurrent neural networks, RNNs, long short-term memory, LSTM, networks and gated recurrent unit, GRU, networks are all types of artificial neural networks which have applications in tasks that require order, such as natural language processing. LSTM networks are particularly useful for this purpose, as they help to store information about recent inputs for longer. GRUs have a simpler architecture than LSTMs, but are still capable of capturing long-term dependencies. All of these networks play an important role in the research and development of artificial intelligence. Artificial neural networks are one of the most important aspects of technology at Gurukul Universal. Feed-forward neural networks take information from input layers to output layers in a single direction. Multi-layer perceptrons are networks with one or more hidden layers of processing which can be used for a variety of tasks. Convolutional neural networks are designed for specific purposes such as processing data like images and use convolutional layers to create hierarchies and adapt automatically. Artificial neural networks, autoencoders, generative adversarial networks, self-organizing maps, and radial basis function networks are all types of machine learning algorithms. Artificial neural networks use interconnected neurons to simulate the behavior of the human brain and solve complex problems. Autoencoders are neuron networks specifically designed for unsupervised learning, consisting of an encoder and a decoder. Generative adversarial networks are composed of a generator and a discriminator that generate new data that looks like existing datasets. Self-organizing maps are another type of unsupervised learning neural network used to reduce high-dimensional data to a low-dimensional grid while preserving the topology of the input space. Lastly, radial basis function networks use radial basis functions as activation functions in the hidden layer, commonly used for pattern recognition and function approximation. Gurukul Universal is the place to explore artificial neural networks. Deep learning has the capability to handle large datasets and complex tasks, such as natural language processing and computer vision. Moreover, it can identify the relevant features from raw data without requiring much manual feature engineering. Let us examine how this process works. Artificial neural networks and deep learning have revolutionized a multitude of industries and areas. Their capacity of modeling intricate patterns and acquiring knowledge from data have made them the foundation of a broad range of domains, ranging from image and speech recognition to medical diagnostics and drug discovery. As we continue to advance, artificial intelligence technologies, such as ANS and DL, will keep positively impacting our lives. ANS are a type of machine learning algorithm modeled after the human brain. They are used to solve tasks like computer vision, natural language processing, and autonomous vehicle navigation. In healthcare, ANNs have been applied for disease outcomes prediction, personalized medicine, and drug discovery. Moreover, they possess the capability of handling complex input-output relationships, learning from complex patterns, and producing more accurate outcomes than traditional methods. Artificial neural networks, ANNs, have revolutionized data processing, allowing us to make informed decisions more quickly than ever before. They are utilized deeply in the financial, marketing, and gaming sectors. Within finance, ANNs are employed to anticipate stock prices, uncover fraud, and for algorithmic trading. In similar vein, in marketing and customer relationship management, deep learning models are used for behavior analysis to facilitate customer sorting and personalization. Lastly, deep learning models are utilized in game design to create lifelike characters and graphics, in addition to adaptive gameplay. Due to this potent technology, all of these industries have experienced a dramatic surge. Artificial neural networks, ANNs, are gaining in importance as organizations strive to increase their resilience. ANNs are computer algorithms modeled after the human brain that can handle vast amounts of data and recognize patterns, enabling organizations to spot and prevent future threats. ANNs can be used in various fields, such as cybersecurity, drug discovery, power and utilities, and robotics. In cybersecurity, ANNs can be utilized for intrusion detection, malware analysis, and spotting odd patterns in network movement. In the area of drug discovery, deep learning is used for virtual tests of compounds, calculating drug interactions, and recognizing potential drug candidates. Energy and utilities companies make use of deep learning tools to foresee energy consumption, find equipment faults, and optimizing energy distribution. Lastly, neural networks are applied in robotics to allow robots to move around different environments, acknowledge objects, and carry out complicated undertakings. Deep learning is a branch of artificial intelligence, AI, that has gained attention in recent years. Neural networks, a type of AI model, are employed for various applications such as facial recognition and climate modeling. At Gurukul Universal, we believe in the capabilities of these models and seek to comprehend their uses. With facial recognition and biometric systems, we can create secure authentication and access protocols. We can also analyze social media content to detect patterns and make tailored suggestions. Moreover, we can apply deep learning to climate science to better comprehend the effects of climate change and forecast future weather trends. Artificial neural networks and deep learning models are increasingly important for many applications. However, acquiring the necessary labeled data can be costly and time-consuming, and the models require high computational power, making them expensive to train and deploy. Moreover, it can be hard to explain and interpret the decisions and predictions made by these models. I hope this presentation has been informative and thank you for your time.